Good day, everyone. We are really pleased to have you join us for a series of community lightning talks on responding to sudden onset and complex emergencies. My name is Carmel Terborg, and I'm the lead account manager for the United Nations here at Esri. It is a great pleasure to be moderating this session and to share the many experiences and insights of your peers on the theme of response. GIS has been applied to some of the greatest challenges facing our world, especially complex humanitarian emergencies, the current global pandemic, and sudden onset disasters such as the explosion in Lebanon last year, and more severe weather events like hurricanes and typhoons. Successfully planning for and responding to these growing threats requires agility and effective communication throughout a crisis. From field data collection to real-time data integration, and from peer-to-peer communications during operations, to the compelling dashboards for the public and decision makers, the work of the humanitarian community in using GIS has already made a significant impact on how disaster response is carried out. With enhanced situational awareness, rapid impact analysis, and easier collaboration during an operation, decisions can be improved and lives can be saved. In this session, you will hear from our presenters how GIS supports many aspects of response efforts: incident management, understanding the impact of a disaster on a community, and the mobilization of essential resources. Our presenters will be sharing their experiences for the next 25 minutes or so, and we will spend the remainder of the hour in a live question and answer session with all of the presenters. Again, thank you for joining us, and now I welcome our first presenter. See you at the Q&A.
Good afternoon. My name is John Morrison, and I'm a planning section chief with the Fairfax County Urban Search and Rescue Team from Fairfax County, Virginia, in the United States. I'm also the Americas region representative for the INSAROG Information Management Working Group. The International Search and Rescue Advisory Group, or INSAROG, is a global network of more than 90 countries and organizations under the United Nations umbrella. It establishes standards for international urban search and rescue teams, or USAR teams, and develops methodologies to coordinate international earthquake response. Why? Because coordination saves lives. Improved coordination in a disaster, and specifically within search and rescue, reduces duplication of efforts and leads to more opportunities to save more lives. Recognizing the need for more effective information management, INSAROG standardized the data collected by each USAR team in 2010, including the form templates for team capabilities, triaging collapsed buildings for rescue potential, reporting on worksite progress, and tracking victim extrications. After trying several open source tools for online-offline data collection, the Information Management Working Group, or IMWG, was founded in 2017, tasked with implementing an end-to-end solution for data collection and reporting. The IM Working Group is made up of representatives from around the world, including Germany, New Zealand, Australia, the United Kingdom, the Netherlands, Singapore, Iceland, and the United States. After the IM Working Group first met, our colleagues from Fire and Emergency New Zealand showcased an ArcGIS system they've been utilizing for post-typhoon deployments. Our working group used that system as a baseline to deploy an end-user-focused solution called ICMS, or the INSAROG Coordination and Management System. ICMS is a collection of numerous ArcGIS products that provides a unique sandbox or instance for each team to train without affecting other teams, as well as an instance for each disaster, which allows for multiple simultaneous incidents to be handled independently. ICMS is built with a wide variety of products from the ArcGIS platform, including app-based data collection, operations dashboards, web maps, web mapping applications, ArcGIS Hub, all scripted from master templates through a Jupyter Notebook. The Jupyter Notebook provides the ability to keep a master copy of all the elements of ICMS and build a new standalone version specific for each disaster response. The multiple-step notebook copies the master template elements and then remaps those new elements to reference each other, ensuring that no cross-contamination of data can occur. Using Survey123 and Explorer for ArcGIS, ICMS allows for an online and offline data collection. After an earthquake, land-based mobile networks are often either offline or swamped with usage. Survey 123's offline option allows critical data collection to continue, and records can be synced once a mobile or satellite network is reached. Explorer allows responders to access maps showing work sites and provides links to create follow-on reports in Survey 123, where common information between record types can be pre-populated, removing duplicative data entry. Custom web mapping applications provide coordination teams the ability to sectorize cities into smaller areas and allows USAR teams the opportunity to review and approve field-submitted reports prior to visualization on a dashboard. The ICMS operations dashboard is tabbed to ensure the correct information is presented to the user based on their current needs. The overview allows for emergency managers to visualize the current progress across an entire disaster response. The team management dashboard details capabilities of responding teams and their anticipated arrival and departure. This enables coordinated efforts with both the airport logistics facilities and anticipated team tasking by emergency managers. The Operations tab within ICMS dashboard provides a detailed view of where work is being performed, where work sites are located that need tasking to teams, and the victim counts and dispositions. The photo gallery provides direct visualization of specific worksite photos collected through Survey 123. Where are we going next? Unmanned aerial system integration, team-based squad-level management, as well as data sharing with partners across the humanitarian space, which will enable improved coordination among all rescue and recovery efforts. Thank you for your time, and I look forward to any questions you may have.
Hello, my name is Pauline McCall, and I'm a solution engineer at Esri. I'm here to present how technology and solutions support collaboration for response across Africa. The Africa GeoPortal is an all-in-one platform that pieces together geographic content and comprehensive WebGIS tools, which are free for single users residing in Africa, those supporting development efforts across the continent, or those working in Africa. Our aim is to remove any barriers that may hinder the advancement of geospatial technology, access to data, and learning for users working in or on Africa. We also aim to provide a sustainable portal of portals for geospatial data focused on Africa. Could be existing data or any new data that will be relevant for developmental goals. Lastly, the Africa GeoPortal allows us to promote premium data, solutions, and value-add services to our communities across Africa. This transparent and collaborative environment applies open data principles in sharing data, apps, and information, making them available to everyone, anywhere, and at any time. Given the numerous challenges we experience as a continent, Africa GeoPortal is a key resource that can be harnessed by individuals, organizations, and nations in collaborating to address these impediments to our growth. Our community of users have access to geospatial tools, a wide array of free learning resources, authoritative content on Africa, impact stories from other community members, focused solutions built from the continent and for the continent, and updates on advancements in industry. Once in the portal, individuals can search for and discover datasets. They can then explore the data to see if it's fit for use. They can visualize this data using the smart mapping capabilities that have been embedded in the platform. They're able to perform analysis on the data if this is required, and finally share the insights with other people. The GeoPortal also enables national agencies and organizations to have a single point for dissemination of authoritative content. With this easy-to-configure platform, organizations can apply best practices in categorizing and managing their data for dissemination, while taking advantage of its secure and scalable capabilities to ensure that all collaborated data is made available to everyone. This will enable better and faster decision making, multi-use of data sets, accelerated innovation and growth, and reduction in the loss of know-how. In the past year, we have seen a community of users leverage the geoportal to maximize engagement, communication, collaboration, and data sharing when responding to disasters in the continent. We saw some of our members visualize the desert locust crisis in the Horn of Africa. Some of our members are also able to configure apps to capture the local perspective from the field. Other community members were able to monitor the trends and effects of COVID-19 in different countries. And this was either using dashboards or story maps, which allowed them to combine media, text, and maps to provide a narrative of the situation in the different countries. Some of our users were able to improve community resilience by communicating to citizens extreme weather and climate events, such as Cyclone Eloise, which affected the southeast part of the continent. And lastly, we've seen some of our members enabling decision making by allowing some of our stakeholders to save lives and mitigate disaster impacts from food security. In conclusion, Africa Geoportal is an open community GIS platform, and we're inviting you to get involved as countries, user communities, industry practitioners, researchers, and leaders, where we ask you to contribute your data, share your success stories on the Geoportal, build tools that others can use, and also just participate either as organizations or countries. You can access the Geoportal with this link, and we look forward to seeing how you use it.
Hello, everybody. My name is Tao, and along with Roman and Masood, we are part of the ICRC, the International Committee of the Red Cross, and today we will show you a few use cases of how we map humanitarian impact. Let's start with Roman in Ukraine.
Thank you, Tao. Today, I'd like to present our case where we use remote sensing data for near real-time wildfire mapping. In September 2020, huge wildfire happens in Luhansk area, Ukraine. This wildfire was even more dangerous than usual one because it happened in conflict area where mines and unexploded objects can detonate. To respond quickly and effectively, we need real-time data about the fire. We used data from NASA's Fire Information for Resource Management System. For our region, it gives possibility to update maps once or even twice per day. So we visualize data and show how the situation changed every day. That allowed us to identify hotspots for our response, like villages, crossing points, infrastructure, and even do some forecasts on the next days. When zoomed to identify hotspots, we can see most affected areas up to street level. And finally, when the fire stopped, we created an overview map to have background for our decision-making process as for the post-fire humanitarian response. Thank you.
And now let's move to Bangladesh with Masood.
Thank you, Thao. Hello, everyone. I would like to present flood risk area analysis using the GIS to support our disaster management response project. As Bangladesh located in monsoon areas, it's facing monsoon flood and flash flood area in hilly areas everywhere. As GIS person, we do analysis using geospatial technique to identify the flood risk area. In workflow, firstly, we prepare socio-economic parameter, land use, land cover, and some flood triggering criteria, slope, elevation, stream density, distance from river in GIS environment. And We calculate weight using the analytical hierarchy process and assign in all layers, and combine all layers using GIS raster calculator in ArcGIS and find the final flood risk map. As a result, it showed that 5.42 kilometers square area, which 50% of total area is high risk. In project is used to show project feasibility, train decision maker, train volunteers who works in the field during the disaster, and shelter mapping. And we have some limitation in analysis and availability of most important triggering parameters, rainfall data, lack of good resolution depth, and short of budget, and lack of geological information. And this is from Bangladesh. Thank you, everyone.
So you might wonder, why is the IC in such places? The ICRC has a very particular purpose. It's part of the Global Red Cross family. It seeks to protect the lives and dignity of victims of war and to help them wherever possible. It is also the guardian of the laws of war, including the Geneva Convention. It is neutral, independent in humanitarian action. We are a GIS team composed of 45 colleagues covering over 75 countries. We support our colleagues in protecting the civilians, visiting detainees and restoring family links. And we also support our colleagues to make sure that the victims have economic security, water and habitat, as well as a health support. Thank you for listening, and don't hesitate to visit our GitHub.
Hello, my name is Keith Cressman. I'm the Senior Locust Forecasting Officer at FAO headquarters in Rome, Italy, where we operate a global desert locust monitoring and early warning system. For the past 33 years, I've been providing forecasts and early warning to countries and the international community. And this is all about desert locusts, the world's oldest and most dangerous migratory pest. It's an insect that lives for about 3 months, and with every new generation of breeding, there's a 20-fold exponential increase. And this is driven completely by rainfall. It's usually severe weather events like cyclones and floods that changes a calm situation and turns it into one that can become a plague. During plagues, a typical desert locust swarm can contain up to 80 million adults in a single square kilometer. And one swarm can be tens or hundreds of square kilometers in size. Swarms migrate downwind about 150 kilometers every day. And swarms can eat an awful lot of crops and pastures. Imagine a swarm the size of New York City. In one day, it can eat the same amount of food as everyone living in New York and California combined. Now, some of you may have heard in the news that East Africa is facing the worst desert locust upsurge in more than 70 years. This started because of 2 cyclones in 2018 in Arabia, where swarms then formed and spread to Southwest Asia and East Africa. Since then, there's been about 10 generations of breeding and a 10 trillion-fold increase in locust numbers. And this is what the results look like. Here we are in the highlands of southern Ethiopia, in Somalia, in Kenya. Swarms have affected communities, and they have become a common sight in the sky during the past year. When this situation becomes out of control like this, hundreds of ground teams are mobilized to intervene, supplemented by aerial control operations. As we speak, we have 28 aircraft operating in the Horn of Africa. But wait a minute. We do not want to reach this point. We want to avoid emergencies. So how do we do it? It is prevention that is the key strategy here. And for this, FAO operates the world's oldest early warning system of any migratory pest. This gives early warning alerts and forecasts so that action can be taken quickly before it's too late. The system relies on 3 core elements: data, geospatial analysis, and value-added information for action. So let's see how these are integrated and work together. Data starts on the ground, where there are specialized locust teams under the national ministries in each country roaming around the desert looking for green vegetation and locusts. They use digital tools developed by FAO to enter their observations and transmit that data in real time. They use drones to cover a much larger area to look for green vegetation and locusts up to 100 kilometers away. We use Earth observation data from satellites to know where it's rained in the desert, where the vegetation is green, and where the soil is moist. So now finally, we get to the Esri part of this story. All of the field and Earth observation data, they are combined into a custom GIS called Swarms that we use for managing the data and analysis. And we've been using Esri GIS products for operational monitoring for more than 25 years. But that's not enough. We're now working with the Esri team to upgrade the Swarms GIS and to take advantage of online functionality and data integration from a greater number of sources in near real time. The geospatial analysis done within the GIS turns the data into value-added information. It's used by countries to plan field operations and by donors for providing emergency assistance. And all of this information is available on FAO's Locust Watch. In addition, FAO has been working with Esri to provide the field data in near real time on the Locust Hub so that researchers and others can use it for modeling and for other purposes. So as you have seen, we harness the latest innovations and turn them into useful tools and products. But this is not enough. It is experience and tacit knowledge that are paramount to the success of any monitoring and early warning system. So while technologies have their role, they cannot replace the human element, but they sure can be of help. Thank you.
Hi, my name is Martin and I'm working with the logistics cluster in Rome, responsible for the field preparedness project activities. And today we're going to talk about LogAI, the logistics information exchange platform that we developed based on Esri technology. The logistics cluster is globally led by the World Food Programme, and together with its over 600 partners across the globe, it provides coordination and information management to support operational decision making and improve the predictability, timeliness, and efficiency of the humanitarian emergency response. Where necessary, the logistics cluster also facilitates access to common logistics services. The information challenge starts already with our mandate: to build a common information platform across hundreds of stakeholders with different information management processes, systems, available technologies, and information standards, and then trying to merge and bring together thousands of different data sources, tables, information sheets, sometimes paper-based, sometimes coming from an SQL database. We are aiming at an integrated information process that allows us, in the acute onset of an emergency, to directly exchange situational information across actors in the field, but also to improve planning, preparedness and readiness activities in a seamless manner, moving from previously assessed logistics capacity information, analytics and forecasts to situational updates on the ground when and where needed. Before going into detail, I want to share with you our vision that led to the first version of LogAI, which we are currently rolling out, targeting up to 20 countries in the first phase.
Following the earthquake, responders must now overcome the challenge of extremely difficult mountainous terrain.
In its wake, the hurricane has left extensive flooding and mudslides. An estimated 750,000 people are currently in need of immediate humanitarian assistance.
What if, when a crisis strikes, there was one information gateway that brought together hundreds of data sources in one location? A dynamic tool capable of integrating and validating information in real time. Technology that changes the way we think, see, and approach humanitarian logistics. What if there's a platform that can analyze and visualize logistics infrastructure, such as warehouse capacity, so responders are better prepared and better coordinated? What if this tool could also map convoys and trucking routes for the quickest and most efficient delivery of life-saving humanitarian cargo? Technology that allows responders to arrive at the hardest to reach locations faster. What if this platform could also combine historic data, mapping and early warning figures to strengthen operational planning and support preparedness activities in the world's most at-risk countries?
The result is an interlinked system using hundreds of standardized global data layers hosted on ArcGIS server in an AWS cloud, updated by server-side synchronization routines from external sources, further utilizing ArcGIS Online web services, and directly integrating field reports via standardized quick capture and Survey 1-3 field reports. This is being provided through a JavaScript API user interface and a lightweight React framework to validate and consume the information, provide comments and updates, access further detailed information, and create on-demand map products. As such, the tool has been built for field conditions that even remote, bad connectivity areas can access crucial information. With this, we are able to set up and establish a system that is accessible for a vast amount of different organizations, users, global, local, national, regional level activities throughout preparedness, readiness, forecasting, and the acute emergency response phase in sudden onset emergencies, for example, as well as long-term, complex, or recurring emergencies. Thank you for your attention.